Okay, everybody, welcome. So what I wanted to do is after, well, I'll get your questions maybe near the end. I hope that you'll found the video that is on Moodle. And well, it's on YouTube, but I post a link on Moodle. That playlist, by the way, if you click like view on YouTube, then that is basically where all the videos are going to go. So if you don't want to check Moodle, you'll just see me adding videos to that playlist. I saw there was like a Joe Rogan one in there that accidentally made its way in there. I must have saved it to the wrong list. So it's now just managerial stats in there. And what I've done, and I'll put this on Moodle after. Let me just maybe share my screen here to get right to the point. I'm going to encourage you guys again to do the homeworks. There's 2 videos to do. Let me share my screen. We'll go with this screen. There we go. Okay, so there we go. Okay, so there's two videos that you need to look at. The probability set is about 25 minutes long, and it's a bunch of extra questions. Again, I chose those ones specifically, and I suggest that you try them out. I think I put the PDF for those on Moodle. I'll double check tonight in case I didn't, but I believe I did. And for the questions I'm about to do, I grabbed some from the homework, and I also grabbed a couple that weren't in the homework, and I thought maybe we would rip through them. So this is not on Moodle yet, but I can certainly put it on there. And before I get too deep, I'm just going to make sure there's nobody in the waiting room. Just give me a moment. I don't think there is. Okay, I hope not. I don't see. Okay, all right. So this was a question that I think was in the homework, but it may not have been. That I thought was good to look at because it's talking about events that are mutually exclusive and not mutually exclusive. And we didn't do a ton of questions that had to do with cards. So cards is just an easy one for probability because, you know, just the nature of cards just makes it easy for it to be a probability thing. So, oh no, I might have to switch my screens here. 1 second. Just because my writing pad is not letting me. One moment. I've never done this over Zoom with the writing pad, so I apologize. I'll try again. Okay. Let's see. All right, perfect. So in this question, we got 52 playing cards, and it says a randomly selected card from the deck is taken, and these are the events as they classify them. So you guys can see my screen, right?
No.
No? Oh, there's people in the lobby. That's because I didn't click share. Okay, now you guys can see my screen, yeah? Someone? Anybody? You guys can see the PowerPoint? Someone will have to speak up because I can only see like, yeah, thank you very much. I can only see one person who has Zach. Zach is brave and has his camera on. So, okay, so the events are defined like this. We got R for red, B for black, A for ace, N for 9, which I thought was weird, D for diamond, and then C for club. And then they give us a couple pairs, and they just say, so for each of these pairs, indicate whether the events are mutually exclusive. So mutually exclusive means that like when you're dealing with probabilities, if 2 things are mutually exclusive, it means probability of one thing happening doesn't affect the probability of, you know, the other thing happening. Okay. So all that being said, so to have a red card and an ace, those are not mutually exclusive. Okay, so not, I'm just going to write ME. So not mutually exclusive. Why? Well, because there are red aces. Okay, so if I draw a red card and then I'm looking to draw an ace, there's a chance that that me drawing a red card, I might have drawn a red ace. So I would write, oh, I'm making a mess. There are red aces. So they can't be mutually exclusive. Take a look at number 2. So this is a red card and a club. Okay, now here I probably wouldn't give this on a test, because, or I'd give you a printout of what a 52 deck cards look like, but clubs are black. Okay, so these are mutually exclusive. Because if I get a red card, it doesn't affect my probability of getting a club. So they are mutually exclusive. Look at ace and N. Now N was 9. I almost had to look back, and I thought that was weird. So an ace and a 9. Well, ace is a particular card and 9s are particular cards. So if I draw an ace, it's not going to affect my probability of getting a 9. So these are mutually exclusive. So that's great. A 9 and a club. So club is a suit, and there's 13. Remember, there's 4 suits. Each suit has 13 cards that go ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king, and I think that's all of them. So there is a 9 of clubs. So these are not mutually exclusive because of that. There's a chance that if I draw a 9, I might draw the 9 of clubs. So not mutually exclusive. So that would affect the probabilities. And then the last one is it diamonds and clubs. So these are 2 different suits. Diamonds are a suit, clubs are a suit. So these are mutually exclusive. So drawing a diamond is not going to affect my probability of getting a club later. All right. So I thought that was just an interesting question. And it is what it is. And I see there's a message in the chat. So, okay. That was from before. Good. Okay. Let's go on to the next question here. Now, this one, I believe, is not from the homework, so I just grabbed an extra one. And I really like this question. Table questions. These are nice probability questions. They don't get too crazy, but they're just the right amount of difficulty, sort of for our class here. So this is all the information that's given in the question. So we got 300 consumers. So right away, they're sort of telling me that the N is 300. Remember, N is just how many, like what's your sample size? And we always talk about it for the rest of the course. So there's 300 consumers between 21 and 49 years old, and they're randomly selected to evaluate a new vodka-based drink. Vodka, perfect. Students love that. After sampling the new beverage, each was asked to rate the appeal of the description. Perfect. And what are the descriptions? Extremely appealing, on a scale of like 1 to 5. 5 being super appealing, and then 4 not being appealing at all. And the table they give us is sort of broken down like this. Over here we got the totals from the male and the females. And so they have sort of gender. Okay, now let's just quickly double check and make sure here, but just to make sense of this table. Yes, if you add up 68 and 83, you get 151. So they basically broken it down by gender, but then they've also broken down by age group. So it's kind of like 2 tables in one. So here's sort of one table. Okay, and if you go 48 plus 66 plus 37, then that also equals 151. Okay, so every row, if you're looking at the gender table, these 2 add up to 151. And then if you look at it broken up by age group, that also equals 151. By the way, if you have a question about this problem, feel free just to maybe speak up when you get it, or you can hold it to the end if you like. So I'm going to do A to E with you guys. Okay, and these questions kind of are all over the map for how hard they are. But A is, what's the probability that they would give the phrase a rating of 5? Okay. And I just want to make sure we're not missing something. Are we missing something here? No. I don't think so. Just going to just double check here. I feel like, did something get covered up? No, everything's good. Okay. Maybe it's just a little bit of confusion around. So, and now we're off the question. All right, we're back. Draw with touch, go to there. Okay. Good. Nope, lost my draw with touch. Okay, here we go. So, someone in a particular age group giving the phrase a rating of 5. So, if you look at your age groups and you look at who gave a rating of 5, then we're going to go 48, because I'm just like, okay, so there's the 21 to 24 group plus everybody in the 25 to 34 group, so 66 plus 37. And then the next question is, well, what's our denominator out of? Well, they didn't restrict it in any way. They just said that any person who was in the survey would give the phrase a rating of 5. So there's 300 people. So I'll give you a moment maybe to type that in on your calculator if you're following along. Literally 1 moment. Now, when I did that, I got 151 out of 300. And when you type that in on your calculator, you're going to get 0.503. So either answer would be fine, but that's part A. Now, are there any questions on that one there?
Professor, yes, there's a question. Can we directly write 151 by 300? Is it necessary that we write 48 plus 66 plus 37?
You know, that's a good question. It doesn't hurt. It doesn't hurt to show the work. Just because imagine, if this was a 2-mark question and then you wrote 150. Because you added something up wrong, right? But if you have these numbers and then you wrote the wrong number here, then I'm like, oh, okay, they made a distraction mistake and they lose half a mark. So that's a good question.
All right, okay, good. And another question, we wrote age groups, we wrote the addition of age groups. Can't we write the addition of genders, like male plus female, by 300?
I didn't get any of that because your mic is very muffled.
You wrote the addition of age groups 48 plus 66 plus 37. Can't we write the addition of genders, like male plus female, 68 plus 83 by 300? That'll give the same answer.
Yeah. Which ones are you adding up?
68 plus 83.
Yes. Yeah. That'd be another way to do it. Yeah, for sure. There's no problem doing it that way because they just said anybody who gives a rating of 5. So remember, you got the 2 different tables that's representing the same data. So yeah, if you went this one plus this one, you'd be getting the same people who rated it 5. I just, for whatever reason, went to the age groups. So yeah, it's a good point. The actual question says, and this is what was confusing me because I feel like it's missing somewhere here, but it says, based on these results, estimate the probability that a randomly selected 21 to 49-year-old person would, and then it goes A, B, C, D. So it's just missing that part. And that's what was confusing me before. All right, any other questions? We'll do B. Would give the phrase a rating of 3 or higher. So remember, the full sentence is, based on these results, estimate the probability that a randomly selected 21 to 49-year-old would give the phrase a rating of 3 or higher. Okay? So 3 or higher means that, you can look at either table, 3 or higher. So you need to go up that way. Okay? So what can we do? I simply just grabbed the totals here. So 3 or higher, well, there was 36 plus, there was 91 plus, and then the 151 that gave a rating of 5. And it's still out of 300 because we haven't put any restrictions on the denominator just yet. So when you add those up, you should get 278 out of 300. And you could leave your answer like that because it doesn't say anything about, if it says round to 2 decimals, then you better give your answer as a decimal. But in this case, it doesn't. So that's an acceptable answer. So 0.927. That's going to stop there. I see there's 2 things in the chat. Would I accept? If it's, yeah, that would work too. Yeah, that would totally work. I would accept 300 minus 13 plus 9, right? Because you're just removing the 2 and the 1. So yeah, I don't mind how you get to your answer as long as it logically makes sense. So in probability, there are often a couple different ways to get there. So certainly as long as you showed your work and it makes sense, sometimes you can just get lucky and you get the right answer. Believe it or not, that actually happens. So yeah, that's totally fine. Any other questions? Wonderful, wonderful. Okay, we can do part C. So part C is kind of like 3 questions in 1 question. So again, the prompt is, based on these results, estimate the probability that a randomly selected 21 to 49-year-old consumer is in the 21 to 24 age group. Okay, so that's the sort of the first part of the question. So a randomly selected consumer in the 21 to 24 age group would be anybody, right? So we're not looking at the ratings anymore. We're just looking at, if I randomly select a person, what are the chances that they're 21 to 24? So that's everything right here. So I got to add up all these. Okay, so I'd have to go 48 plus 36 plus 9 plus 4 plus 4. And then it said just out of anybody, so out of 300. Okay, and I should write, this is the probability that we're 21 to 24. So your work might look something like this. So when you add those up, to save you some time, you add up 48 plus 36 plus 9 plus 4 plus 4, you get 101 out of 300. Equals this, 21 to 24. So if you type this in on your calculator, you get like 0.337 or something like that. So that's one part of C. The other part of C is they're looking for the probability that a randomly selected person is 25 to 34. Okay, so now I'm just looking at this column here. So I'm going to add up all these numbers. So my work might look something like this: 66 plus 36 plus 12, and then 6 plus 3 is 9. So I'll just do that because I'm kind of running out of room. So again, the 9 is because I did 6 plus 3 and just wrote 9. And when you add that all up, where's my work? I got 123. Which, if you type it in on your calculator, 0.41. Now actually never do this. Never do what I just did here, like as far as your work goes. I got 2 equals on the same line. Never do that. It's you can't do that in math. It's just, yeah. You can only have 1 equals on each line. So, and I am a bit of a stickler for that because it just doesn't make sense. When I see it, you're physically hurting my brain, okay? And you don't want to do that to the person who's marking your paper, okay? But I do it all the time because I run out of room. But yeah, do not do that. Okay, last one. I might just give you the answer to this one and not, like the 35 to 49 age group. So we're still doing part C, but now we're doing the probability of the 35 to 49. Right, so you're adding this column here, everything in that column. And when you do that, I'll just give you sort of the final tally. You should get 76 out of 300. And that is, yeah, don't go on the same line. So you get 0.253, 0.253. Okay. Any questions for part C? Where we get to the very interesting D and E. We'll switch to a new slide. It's the same question, just fresh paper, so to speak. Okay, so let's do part D here. What do we got? So remember, the prompt is, based on these results, based on the table, estimate the probability that a randomly selected 21 to 49-year-old consumer is a male who gives the phrase a rating of 4. Wonderful, wonderful. Male who gives the phrase a rating of 4. Okay, so when you look at your table, so we're probably pretty clearly here in this one here, the one where it's male or female. Now a rating of 4 and male, there we are. So rating of 4 and male, it's 51. And then there was no restriction on the denominator, it said randomly selected person. So we're not looking at a specific group. So it's just 51 out of 300. And if you want to write the probability, 0.170. There. Well, that one's fairly straightforward. And then E, so again, the prompt is, based on these results, estimate the probability that a randomly selected 21 to 49-year-old consumer is a 35 to 49-year-old who gives the phrase a rating of 1. So it's kind of similar to D. But now we're looking at the age groups. So first of all, 35 to 49 is this column. And then a rating of 1 is down here. So there it is. 2 out of 300. Type that in on your calculator and you'll get 0.007. So either way you leave the answer is fine in this case. Questions about this question? All right. Perfect. Well, if we are feeling good, we can keep going. Now, again, I can't remember if this was in your homework or not. I closed the homework, so I think this one is, but then the next one I do isn't maybe, but anyways.
Yeah, this one's in there, yeah.
Oh, okay, perfect. Thank you. Now, I chose it because it's an even numbered one, and I don't recall if in this particular week I haven't put the detailed solutions up until you get to like I think the next week. So you might not have this particular one. I think you just have an answer or something like that. So anyways, for this one here, 3.32, this is the entire question. So when you read through, it says 15% of the employees in a company have managerial positions, and 25% of the employees in the company have MBA degrees. Okay, so like when I read a question, I sort of read through it once just to read it. What else do we got? 60% of the managers have MBA degrees, and then use the probability formulas to find the proportion of employees who are managers and have MBA degrees. Okay, the proportion of MBAs who are managers. And then part C, something about independence. So I read through it once and I'm like, okay, so we got, you know, MBAs, and then we got managers, and then we got people who maybe have both, right? So the first time I read it through is just to figure out, okay, what are my variables? Then I probably read it again, especially in context of like, I might be like, okay, well, if I'm going to do A and I read through it again, let's see if I can figure it out here. So we need to find the proportion of employees who are managers and have an MBA degree. Okay, so we're finding the probability of manager and MBA. Remember, this is the symbol for and. Remember, my trick is if you just draw a horizontal line here that looks like an A for and, okay? And might be useful to go to the formula sheet and look this formula up, right? Because it actually is a formula from your formula sheet. Now, excuse me, because I think the formula sheet I have open is the final one. I'll just drag it over here for a moment. It is the final one. Okay, so well, if I just stick here, then it won't scare you because we won't go any further. So here it is. If you're looking for A and B, so two events happening, you know, you write it like this, A and B, and then you need to find the probability of A multiplied by the probability of B given A. Okay, so in the context of this question, right, because my formula sheet just has A and B on it, it's helpful to write it out in words. I can't stress enough, at least for me, like you need to write it in words. So we need to go, so remember, this is like A, and this is like B if you're looking at the formula sheet. So we need probability of A, which is manager, times probability of this one, MBA, given that they're a manager. So remember, the word given is sort of this vertical line here. And now I read the question again because I'm like, well, do I have any of this information? Like I want to avoid making a table if I can, because sometimes all the information you need might be just in the question. So if you look through, it says 15% of the employees in a company have managerial positions. And then it says 25% have MBAs. So probability of being a manager is right there. It's 0.15, 15%. Just remember, you need to convert it to a decimal. Don't remember, just 15 divided by 100. It's going to give you that. Now, times. Do I have the probability of having an MBA given that you're a manager? So I'm going to read through again. So I already used this piece of information, so that's fine. 25% of the employees in the company have MBA degrees. Also, 60% of the managers have MBA degrees. So there it is. Probability of having an MBA given that you're a manager, that's this number right here, right? So managers who have MBA, that's this, okay? So I have that, it's 0.6 or 60%. And now that I have all the work, okay, so this would actually be quite possibly a 2 or 3 mark question because I'd be looking for like, okay, well, they need this first line, right? Because realizing that I'm asking for that. So just getting that far gets you a mark. And then probably half a mark each, right? Half a mark for the 15%, half a mark for the 60, and or maybe I do like I probably actually do 1 mark here, 1 mark here, and then like half a mark here, and then half a mark for the right answer, something like that. So when you multiply them together, you get 0.09. That's kind of tricky. Like it's, we went to the formula sheet, we grabbed a formula, we had to read the question a few times, okay? As much as possible, I try to demystify my thinking process. So I do read the question multiple times usually, because you have to. So part B, finding the proportion of MBAs who are managers, okay? So this is probability. So the proportion of MBAs who are managers. So if you're a manager, oops, that's an A right there. So manager, given that you have an MBA. Okay, then you can literally go to the formula sheet and go look this up. Okay, so on the formula sheet, it looks like, oh, it's over here on this screen. Where is it here? Yes. So I have it like this. So whatever is over here is B. Let's see if I can write that. Whatever I have over here is B, and whatever I have here is A. And on the formula sheet, it says probability of basically A and B, or B and A is the same thing, divided by, let me bring that formula sheet back, probability of A. Probability of A. Okay, so let's see. So in our case, we're looking for probability of manager and MBA, like that, divided by, so it says probability of A, which is probability of MBA. There we go. Now, if you look very carefully, we actually figured out the numerator in part A, right? That was probability of manager and MBA. So we actually grab our answer from part A. And never fear. So if this was a test or something and you didn't get part A, or you got the wrong answer, I suppose, I would ignore that this number here was wrong. I'd just be looking for you to take whatever number you had here and put it in part B, okay? And probability of MBA, well, is that given? Let's see, you got to read the question again. 15% of the employees have managerial positions and 25% of the employees have MBA degrees. Well, perfect. I'm looking for probability of MBA, and they gave it in the question, so 0.25. There you go. Now, I'm running out of room, so I am going to just draw an arrow here, but if you have room, go to the next line. But that is 0.36. So there you have it. All right. Good stuff, good stuff. So next, last one. Are the events being a manager and having an MBA independent and justify your answer? Well, if you check your formula sheet, for them to be independent, you have to satisfy basically this condition here. So the probability of manager, given that you have an MBA, so the probability of you being a manager, given that you have an MBA, has to equal the probability of being a manager. So if those two probabilities equal each other, then they're independent. If they don't equal each other, then they're not independent. So this question's set up in such a way that when you get to part C, you should have all the information you need. So in part B, we figured out probability of being a manager given you have an MBA. So that's 0.36. And now, is that equal to the probability of being a manager, which is given in the question? Oh, no. Did we find it somewhere? Manager.
The part A, wouldn't it?
Yes. Perfect. Thank you very much. I was freaking out there. So, thank you very much for chiming in. Yes, probability of manager is 15%. So, are those two numbers equal? Notice I'm putting a question mark, right? Because if you don't put the question mark, then you're saying they are equal, and they are not equal. Okay, so you can put a line through there. So you can say, therefore, they are not independent. So no. they are not independent events. Thank you very much for the save. All right. That is a tricky question. Now, I really, because I see it's 9:51, and I'm happy to stick a little bit past 10 o'clock if you have extra questions, but I don't want to keep anybody longer than that. And I think this is a good question. I like it. So it is 3.35, and I don't think it's part of your homework. Pretty sure I grabbed an extra one here. So this is not part of your homework, but it is a good question to do. So here we are. And the question's in red, so it is 3.35 if you want to go find it in the book if you have one. So it says in a survey of 100 insurance, should say claims. So in a survey of 100 insurance claims, 40 are fire claims, and 16 of these claims are fraudulent. So we got 40 fire claims, and 16 of the 40 are fraudulent. And then it says also there are a total of 40 fraudulent claims. And then part A says, construct a contingency table that summarizes the data. So contingency table is just a fancy way of saying, make me a table, right? So where'd it go? In this question, this is like a contingency table, so to speak. So that's what we're doing here. Let's make a contingency table. Wow, excuse my drawing of the table because it's gonna be crooked. We know it's gonna be crooked. So let's just make a square box, and then you're going to need sort of like 4 columns. 1, 2, there we go. There's 4, and then 4 rows. 1, yeah, 2 rows. There we go, 4 rows, not bad. How would you guys rate this table? I think it looks pretty good. So what do we got? Well, we got fire claims, and then we got fire claims that are fraudulent. So it doesn't really matter where you put it, but I'm going to put fire right here. And then I'm going to put not fire. Okay, so we got fire, not fire. And then we got claims that are fraudulent. So let's put fraud. And then I'll put, oops. Maybe I can get the eraser here. Then I'm going to put not fraud. Okay. So F-R-A-U-D. And then remember, putting a line on top means not fraud. I should use my rainbow pen. One moment. Not fraud, not fire. Okay? Here we go. So got our table. Now over here, we'll have the total of 100. So that's given in the question. It says there's 100 insurance claims. All right? And 40 are fire claims. Okay, 40 are fire claims. So see the row that has fire? Well, these are the totals. So if you want to write totals, you can. I usually don't, but these are the totals. So 40, this should add up to 40. So we got 40 fire claims. Then it says 16 of those fire claims are fraudulent. Okay, so of these 40, fire and fraud, there's 16 of them. So you put 16 here, right? So fire claims that are fraudulent, 16. Okay. And it says also there are a total of 40 fraudulent claims. So where's fraud? Here's fraud. So there's a total. Remember, these are the totals. So total of 40 fraudulent claims. So that's all the information that's given in the question. 16 fraudulent fire claims, 40 total claims that are fraudulent, and then 40 claims that are fire related, and in total 100 claims. You got to calculate the rest of the stuff. Okay, well now, and this isn't too bad. Maybe I'll write it in a different color because anything in green, I suppose, will be calculated. So if there's 40 fraudulent claims and 16 of them are related to fire, well, then there must have been 24 non-fire claims, right? 40 minus 16 gives you the 24. Then I can go over here and I can say, okay, well, I got 40 fire claims in total. 16 of them are fraudulent. So if you go 40 minus 16, you're going to get that 24 of them were fraudulent. Oh, sorry, not fraud, not fraudulent, not fraudulent. I missed the bar. These are not fraudulent. So let me say that again. We know that 16 of the fire claims are fraudulent. We know there's 40 fire claims in total. So when you go 14 minus the 16 fraudulent, you're left with 24 not fraudulent fire claims. Very sorry. Okay. What else? What else? What else? We can get this number here, right? Because I know there's 100 cases in total, so there's 40 fire, 60 non-fire, right? So 40 plus 60 is 100. And then that lets me get this number here, 60 minus 24 is going to give me 36. So there's 36 not fraudulent, not fire claims. And then I can just go 24 plus 36 to get the 60 here. And you should also double check 40 plus 60 should be 100. So that's part A. That's perfect. Sometimes that's worth marks and sometimes it isn't. I guess it depends how generous I want to be. But sometimes you might just have to do this to do the actual question that it's asking. So part B. Part B, we're going to be using the table. What proportion of the fire claims are fraudulent? All right, so what proportion of the fire claims are fraudulent? Well, there are how many fire claims? 40, right? And 16 of them are fraudulent. You didn't need the table to do this. They did not need the table to do that. So you can leave your answer like that. If you do type it in, you get 0.4. I could ask, like, there is no question that really uses the table. I don't know if I want to make one up on the spot. I guess I could say, we could, let's try, what is it, 958, sure, let's see. So if I ask you, what's the probability of, let's do this, probability of choosing so probability of doing a non-fire claim. So you pick a claim, what's the probability of it not being a fire claim? So there's 100 claims, so we know the denominator. And then if you look at the table, and this was not given in the question, right? We calculated it because it's in green. Well, there's 60 non-fire claims. So there's one. This is not part C, this is just an extra. You can do another extra. Let's try to make it a little bit trickier. So maybe what's the probability? I don't know. Having a, let's see, not fraudulent and not fire claim. So probability of just randomly selecting a claim, so it's out of 100, that's not fraudulent and not fire. So you have the table, you go, okay, so not fraudulent is here, not fire is here, so that's 36. Now that seems really easy, right? But remember how long it took us to make the table, okay? So when you have the table, you're very powerful because you can answer a lot of questions. I'll ask one other extra one, just because I'm avoiding part C, because it's a pain. What are we gonna do? Let's go probability of, see if I can do this right, of selecting a claim that's fraudulent or a fire claim. So probability of getting a fraudulent claim or a fire claim. So there's two ways to do this. You can use the formula. Where is it here? Close that. Get it here. Oh no, sorry, should have never done that. Okay, here we go. Formula paper, right here, right? Probability of A or B. The thing that makes this question a little bit trickier is you can go probability of A plus probability of B, but you got to subtract the overlap. So if you're using the formula, then you got to do it that way. If you have the table, I prefer to think of it a little bit differently and just remove the overlap as I do it. So this is what I mean. I'm just going to go find, so I know it's out of 100, right? Claims that are fraudulent, right? There's 40 in total, 16 here, 24 here, total is 40. Then I'm going to add the fire claims. This is where you need to be careful, okay? Because the fire claims, see how there's that overlap of fraud and fire? That's within the 60, right? 16 plus 24 gave us, sorry, I should have said 40, right? It's within that 40 already. So when I do my fire claims, I'm like, I already counted that 16. So there's only 24 more claims, okay, that are fire related. And there you have it, 64 out of 100. Now, if you do want to use the formula and go probability of fraud plus probability of fire, and then subtract probability of fraud and fire. So it's going to go F and F. So probability of fraud is 40 out of 100, plus probability of fire is 40 out of 100. And then the overlap, the fraud and the fire, is 16 out of 100. And if you do it that way, you get 80 minus 16, and so you still get the 64 out of 100 we had before, okay? And I'm actually going to leave part C because it's 10:02, so I don't want anyone to feel like they need to stay past 10 o'clock because our class is normally over at 10. I am happy to do it. I'm just going to say I'm going to do it on overtime, so if anybody wants to leave, they're fine. I should say, are there any questions at this point, maybe about the week or anything like that? Any questions?
I think that there's a little mistake in the formula sheet.
The one that's posted on Moodle?
Yeah,
Let's
it's not the
go.
end of the world, but it's,
No, I appreciate you pointing it out. Where did you grab the formula sheet from? Do you remember?
it was the complete one on Moodle.
The complete one?
Yeah.
Let me switch to student view. One moment. So it'll be in the folder that's right at the top that says formula, paper, and tables.
I think so, yeah.
Yeah,
I can't
okay.
remember.
I'll quickly download that one. Where's the mistake?
It's under probabilities and then the multiplication rule. It's in that formula. It's just a small mistake.
I'm just opening it right now. Is it gonna open? Oh, there. Where is it? So I have two monitors, and sometimes when I have Zoom open, it's just too much. Where did it go? Come on. It keeps, no, that's not. Okay, well, where's the mistake? Oh, here it is. Where's the mistake? On multiplication?
Yeah, right at the end where it says P and then B/A.
Should be vertical.
Yeah.
Yes, very good eye. Thank you very much. So anyone's looking at that, yeah, I don't have editing on here, but yeah, that should be vertical line, yeah. Yeah, otherwise that kind of looks like division, and that's not good. It should be more like that. There we go.
Yeah, that's what I was confused.
So I'll try to correct that. Yeah, no, that's a good point. Thank you very much. You guys are good at finding mistakes. But that's good, yeah, because I make lots of mistakes on purpose to test you. See who's listening. Yeah, I will definitely correct that on my copy, and then I'll re-upload it to Moodle. Is there anything else? Are the videos are okay? Like, you guys, I don't know, we're in a brand new world. Thank you, Zach, for that thumbs up. Yeah, I think you're the only person. I'm going to stop sharing for a moment so I can go back to the meeting and just, well, nobody's sharing their video anyway, so that's okay. Yeah, well, I will continue to post these videos, and I will continue to try to do, so my vision is sort of, I'll have like a lesson video, which goes through the notes that are on Moodle, and then I try to have a couple like extra questions and things like that, and then we'll meet, every week from sort of, 9:15, 9:20 to 10 or so, to just get in some extra time. And next week, if you guys are still hanging around, next week we are slated to have, let me go check, I believe it's sort of the first lab. Let's check my stuff, sorry. Pretty sure it's the first lab. Anyone remember what the course outline says? I just don't have it open in front of me, so I don't want to say the wrong thing is all. Let me check. I'm getting there. Week 3, no. Week 3 is another group of lessons. I will check the course outline. Nobody's there. Everybody walked away from their computer, so I'm just talking to nobody.
The lab would be on the February 1st.
Thank you. I'm just opening the course outline here just to confirm. Yeah, in my schedule, I got January 25th is indeed another chapter. Yep. So there'll be another set of notes. I can quickly share my screen here. Thank you for chiming in there. Too many monitors. It's supposed to make things easier, but there's the course outline. Let me share it for a moment. So yeah, next week we will be doing chapter 4. So I'll be posting the videos on Friday, so you guys can review them early if you wish. And then on February the 1st, we'll have our first lab, and if there's any bleed over from chapter 4, we'll do it then as well. So I'll stick around if you guys have any questions or comments or concerns. But otherwise, we did a couple more questions. Is there any assignment this week? Oh, and videos are great. Thank you very much. Yes. There's no assignment that's worth marks. Okay, so it just says practice posted on Moodle. I can drag my Moodle over here.
If we have a solid understanding of the homework questions, is that enough to prepare us for the midterm?
No. It's it won't be, you'll like, okay, you'll be on a very good road. Yeah, so doing the homeworks is key. Making sure that you understand everything in the notes is key, right? Because the notes, that's where, and it'll be more and more as we go forward, but the notes will have more and more theory. Okay, now theory is one of those things where it's like I can give you a theory, I can give you 100 different questions about the theory. Okay, so we haven't seen a lot of that just yet. So when I say you need to understand the notes, you need to understand any theories that are in there. The last part of doing well on the midterms is doing the midterm practices that I will release, in addition to the labs. So the labs help you, because the labs are like extra questions, they're just worth marks. And then the midterm practice is like, I try to give you a very good idea of what to expect on the midterm, and I give you a midterm practice, okay? I'm not saying that my midterm practice is exactly like my midterm, but if there's a concept you don't get on the midterm practice, you're in trouble, and you probably need to talk to me, okay? So homeworks, midterm practice, that's the short answer. Yes, then you're on a good road. And the notes, the trifecta, the 3. Did I answer your question okay?
Yeah, that clears it up.
Okay, and I'll have to, by the way, if you're looking at Moodle, I'll have to modify this because in previous years I did it in a bit of a different order. So, or maybe not. Let's see, week 3. Yes, no, this is correct. So on Moodle, it is correct. So just a reminder, you go on Moodle, check out week 3 homework, and you can download the actual homework. Now I do start having detailed solutions for this week, and this one right here should be, this Word document should be the homework. And then there's some extra practice, okay? And I will post some extra practice on Moodle, or sorry, on YouTube, which will be on Moodle, okay? So Friday, I'll release that early, and then on Monday, we'll do our lesson on that, okay?
I had another question for the test.
Yep.
Like, will we be able to use paper and kind of figure it out, or is it all going to be on the computer? How does the test setup work?
Yeah, that's a good question. I do envision that you're gonna need paper, but because I'm trying to use Top Hat, which is a nightmare, basically, is what I found out so far. But I'm gonna use Top Hat. I'm changing the format of the questions so that, yeah, you'll need to do your work on paper and then input your answer on whatever Top Hat, if that makes sense.
Okay, I was just kind of concerned for time, but
yeah, and the final time it takes depends on how long it is, but I usually do about an hour to an hour and a half, usually around the 1 hour mark, but I give you like more time. So yeah, if you really want to know, when I make a midterm, I write it myself, and then I multiply the amount of time it took me by like 3 or 4. So if it took me like, you know, and I write it out completely, right? So if I show all my work and, show all my work, and it took me, 15 minutes, then I'm like, okay, so then they need like an hour or something like that. That usually seems to be about right? Because I've been doing this for a long time. So for me, and I wrote the test. So 15 minutes for you guys might be more like, 40 minutes to an hour of actual time, right? I don't know if that answered your question, or just gave you more anxiety or something. Anything else? Anything else?
I have a question.
Yes, sir.
So where is the bonus assignment for this week?
Where's the bonus assignment? I need to release a bonus assignment. Can I, and I know I said I'd do it today, So that's a good that's a good point. Can I, because I think I'm gonna give it to you guys a little bit later in the week. Because when I was really thinking about it, I'm like, okay, well, you know, some people, right, who are really following the schedule might have just viewed the lesson today, right? So I want it to sink in. I want you to have some time to do the homework, and then I will release a bonus assignment. So what I'm going to do is I will send an email. So check your email, but let's aim for Friday. So on Friday, I will release next Monday's stuff, and I'll put the bonus question up. And I believe, because I haven't done it yet, I believe it's just going to be a question, and you're going to submit like a picture of your work. And I do sort of want it, I'll leave it up for the, I haven't decided yet, so I'm just stuttering here. What do you guys think is good? Like leave it up for the day? Would that be a problem? So if I put it up at like 9 in the morning or something, and just said it's due by Saturday morning, would that be unreasonable? It's one question.
You'd put it up on
That sounds
Friday?
fair, yeah.
On Moodle, yeah, it'd be on Moodle. I'll send you an email with a link to it as well, but it'll be on Moodle too. Yeah? Do Sunday? It's one question. It's one question. Like it should take you, it shouldn't take you 2 days. Are you asking Sunday just because you're busy on Friday and Saturday or something, or what? Oh yeah, yeah. Okay. Oh, you know, I suppose for the first bonus, I suppose. Yeah, yeah. Okay, for the first bonus, I'll put it up on Friday, and leave it up till Sunday, or I'll take it until Sunday rather. Okay. All right. Great. See, people are slowly filtering out, so no problemo. I'm gonna stop the recording.